like a bell curve here. So a normal distribution is that the data varies randomly from the mean. And remember, the mean, the symbol is an X with a bar above it. It is a bell-shaped curve. So, in medicine here, the bar graph below gives the birth weights of a population of 100 babies. The red curve line, this is a red curve line, shows how the weights are normally distributed about the mean, which is, who weighs babies in grams? I guess this one does. Which is, here's your mean, which is 32,000, or 3,250 grams. And you can estimate the percent of the babies weighing between 2,500 and, which is here, to 3,900, which is here. So if you look at this, on here, estimate and add the percents, I would be adding up all of these numbers here. The percent here, this bar graph, is around 23%. This one here is 42%. And this one here is 23%. Look how nice and symmetrical that is. This is called a perfect situation type of thing. So you add up all of those and it's 88%. So about 88% of the babies weigh between 2,500 and 3,999 grams. Okay? So now in here, the jaw widths of a population of great white sharks are normally distributed about the mean of 15.7 inches. For the given population, the standard deviation of the jaw widths is 2.8. Sketch a normal curve showing the jaw widths at 1, 2, and 3 deviations from the mean. So here is my mean. I am adding 2.8 to 8. Notice, let's see, this is a 0.1 deviation. This means plus or a plus 1. That's 1 deviation above the mean. This is 2 deviations above. This is 3 deviations. Here's a -1, -2, -3, and everything is 2.8 away from the previous deviation, standard deviation. And your curve would look like this. Okay? Makes sense, right? Okay, so now let's look at this. Sketch a normal curve for each distribution. Label the x-axis values at 1, 2, and 3 deviations from the mean. The mean score is 45 and the standard deviation is 3. So I just draw a line here. And here I have 45 is my mean. So that's going to be the top of my graph, of my bell. This is the x. So at 1 standard deviation at a +1, it would be at what? What would the number be here? 48, because I add 3 to it. And this is at your +1. This would be here, well, I got to do it more symmetrical than that. This would be what? 51. This would be +2. This would be 54. This would be +3. This would be -2, which is, oh, Cheryl, not negative. 42, which is a -1. This is 39. This is a -2. Have statistics just make logical sense. Don't try and make it hard. It's not. Okay? So now what it's going to do is it's going to go like this. Whoopsie, I got one. And you try, whoa, I didn't do that very good. Bad girl. Okay. Try and make it as symmetric so where you intersect your line here is at the same place. And mine didn't do so well. I should have done it with a pencil and I could erase. So that these are across each other. That kind of shows that your bell curve is very much the same. Okay, so when you show probability distribution as a bar graph, the height of the bar for each outcome indicates the probability. So for a normal curve, however, the area between the curve and the x-axis represent the probability. And you're going to get into something here. So if you had a bar graph, your bar graph would go, I'm going to do this in pencil because I might make boo-boos, would go something like this. Whoa. What, honey? And then you would have this here. This would go like to half of it. And then this would go to half of it. And then this would go to half of it. Does that make sense? Mine didn't turn out so nice. Miss Artist, I'm not. Okay. But you're going through those where they intersect. Okay. Now, a standard normal curve. Okay. These percentages always stay the same. Okay, so on here, a standard normal curve is a normal distribution centered on the y-axis. The mean of the standard normal curve is 0. The standard deviation is 1. Are we listening? Okay. Between here, this is always going to be from the +1 to -1. This is always 34% to the left and right of the mean. So within one deviation, you should always, in a standard normal curve, it will be 68% between one standard and a +1. Okay? Then at 2, between these two, it's going to be between the two standard deviations, you will have 95% of your population will fall between the two standard deviations. Then from the on to the end is 2.5, and that adds up to 2. But I would like to add one more number in there, and that's what I was talking to Ms. Shea about, because I knew there was another one, about the third deviation. This is 2.5 from here on out. But from the second to the third is 2.35. Okay? So here, and this is 2.35 from here to here. The 2.5 is from the second to the end. So this is basically 0.15 at the end. So between my three standard deviations, it is 99.7%. Our book doesn't include this, and I don't know why, because this is called the empirical rule. They don't teach you that name, but you will see it in your statistics class. That in a standard normal curve of distribution, within one standard deviation, it'll be 68% of the population of your data will fall within one of both sides. Within 2, it will be 95%. Within 3, it would be 99.7%. Okay? And then this is the rest of the residue that goes out to this. Okay? So how does that help us? Let's see what we can do with that little statistical number. Okay, every normal curve contains the same probability distribution. This is called the probability distribution. What is this titled? Normal distribution. It's of the normal curve. These are your percents. Okay? So, when a set of data is normally distributed, about 68% of the data fall within one standard deviation of the mean, about 95% of the data fall within two standard deviations, and now you know about the 3 standard deviations. We kind of increased it. We are not going to worry about the z-score. Okay? So, on here, in a survey, the responses to the question, how much time do you spend at meals in 1 week, were normally distributed. The mean was 13 hours. The standard deviation was 3. So if you have this, if the mean was 13, the standard deviation, what are the values, one standard deviation from the mean? Think about it logically. You don't even need to know all that. It would be adding and subtracting what? 3. So you'd have 16 and you would have 10. Here it is, one standard deviation of between. How much of your data should be between that? 68%, right? 34 and 34. Because this is a -1 standard deviation, this is a +1. This is your mean. What percent of the responses would you expect to find between 10 and 16? What does it say? 68%. Okay? Questions? Pretty logical right now. Okay, now let's go to the back, and then we're done. Almost. Woohoo! Our last chapter is trig. Okay. In a survey, the response to the question, how much time do you spend in the shower? We're normally distributed. The mean was 15. The standard deviation was 2 minutes. What are the values? What values are one standard deviation from the mean? What would it be? 17 and 13 or 17. If I would draw my little curve so that you make sure you understand this, here's my mean. One standard here's where the top of the bell goes. Then we have 17, we have 19, we have 13, we have 11. Okay, and you would have here, and I'm going to try and draw it better. I'll draw my little dots. So I still don't do well on the left side. Okay. So by that bell, by that normal distribution, this will be 34%. This is also 34%. Then this is 13.5%. This is 13.5 because when you add this is 68. This has to be 95. 95 minus 68 is 27. Divide 27 by 2, and that's where they get the 13.5. Yes. It is fixed in a normal curve. That's what makes it standard. A standard normal curve. And then we would have our 2.35 out to our third one. And 0.15 to the rest of the molasses. So on here, if this was, or we should say or, less than 13, so less than 13, this really makes up 2.5%, the 2.35 and the 0.15. Less than 13 would be 26, right? Greater than 17, sorry. Greater than 17 is also 26. Am I doing this right? This is 16, so sorry. I got my numbers mixed up here. This is 16, and this is 16. Bad girl. So you get 32%. What would it be if I'd ask you between 13 and 17? What would that be? Between 13 and 17, what's the percent? 68%. How about between 11 and 17? No, 11 and 19. Such a silly girl. What would that be? 95. It's always 95. Huh? You add them. Because it's between the two standard deviations. Two standard deviations to the left and to the right is always 95%. So now here I don't want this to throw you. They just did, here's our mean, Here's our -1, our -2 is right here, deviation, and they have 2.5 because they aren't going to the third. Remember, the 2.35 plus 0.15 adds up to 2.5. Okay, so here in a university class of 174 students, the final exam scores have a mean of 68.5 and a standard deviation of 7.3. So here's my mean. They subtracted 7.3. They added 7.3, okay? And they are on a normal curve. Find the number of students who received a grade from 1 to 2 standard deviations. So between 1 and 2 standard deviations would be here. Okay? How much did that, what is the percent there? It's 13.5%. Because this is your +1, this is your +2. Between 1 and 2. So you take 0.135 times 74. Between about 23 or 24 students receive grades of 1 to 2 standard deviations above the mean. Okay? So on here, find the number of students who receive grades of 61 or below. That would be 13.5 plus 2.5, which is 16. So I take 16% of that, and you get 27.84. So you have around 28 students. I don't know why they just didn't say 23 students there. Maybe because it was so in the middle. So here, a set of data has a normal distribution with a mean of 50 and a standard deviation of 7. Find the percent of data within each interval. Change this to 43 because we can't do it that way. So if it's less than 43, what deviation will this be at? A -1. So I'm talking about everything below -1. What would that be then? %. If you can't figure it out, if you don't see it, draw your little thing. Here's 43. Here will be 36. Here would be 29. Add 7, you'd have 57. You'd have 63. You would have 70. So here are your deviations. So less than 43. This is 34, 34. This is 13.5, 13.5. This is, and below, this would be 2.35, and this is 0.15 for the rest of it. We aren't going to talk about 4 deviations. We don't need to do that. So if we're talking about less than 43, we're talking about 16%. You're adding these. Okay, change these numbers from 43 to 57. So from 43 to 57, we're talking about 68%. Greater than 50. Greater than 50 should be what? 50%. Any questions on that? Okay. Okay, one other thing.